Good evening. Let us start solving sums on induction. I think only few sums are left. We have to solve sum number 14 from exercise 4.1. Now, 14th one, using method of induction, prove that cos theta plus I sin theta raised to n equal to cos n theta plus I sin n theta, where I is an imaginary unit, iota I equal to root of -1. Okay. So let Pn denote this statement. Now step 1, for n equal to 1, what is LHS? It is cos theta plus I sin theta raised to 1, means what? Cos theta plus I sin theta. What is RHS? Replace n by 1. So same, cos theta plus I sin theta. So LHS equal to RHS, that is P of 1 is true. Second step, let P of k be true for k belonging to n. That is cos theta plus I sin theta raised to k is cos k theta plus I sin k theta. Number 1. In the step 3, this is the most important step. We prove that P of k plus 1 is true. Means what? Replace every k by k plus 1 in this result. So cos theta plus I sin theta raised to k plus 1 is what? Cos of k plus 1 in bracket into theta plus I sin of k plus 1 into theta. We have to prove this. We begin with LHS. LHS cos theta plus I sin theta raised to k plus 1. Laws of indices. So this is cos theta plus I sin theta raised to k into cos theta plus I sin theta. From 1, this is what? Cos k theta plus I sin k theta. Open the bracket, you get 4 terms, right? Cos plus I, cos sin plus I, sin cos plus I, that is I square, sin cos. But what is I square? -1. Now cos k theta cos theta minus sin k theta sin theta is cos of k theta plus theta. Reason, cos of alpha plus beta, cos alpha cos beta minus sin alpha sin beta. Similarly, what is sin of alpha plus beta? Sin alpha cos beta plus cos alpha sin beta. Now take theta common from these two terms. Same thing here. You will notice that this is nothing but RHS. Therefore, P of k plus 1 is true. So, step 4, from above steps and by the principle of method of induction, P of n is true for all n belonging to n. That is cos theta plus I sin theta raised to n is cos n theta plus I sin n theta, where n is natural number. You have to impress the teacher not by giving note but by writing note like this. Of course, you should know this, that this is De Moivre's theorem. Sum number 15. Let me explain. You have to write the solution after the lecture. Given that Tn plus 1 is 5Tn plus 4, T1 is 4, prove by method of induction that nth term is 5 raised to n minus 1. Let Pn denote the statement that Tn is 5 raised to n minus 1, where Tn plus 1 is given to be 5Tn plus 4 and first term is 4. Step 1, for n equal to 1, what is T1? It is 4 given. Okay. Now put n equal to 1 on right hand side. So 5 raised to 1, which is 5, minus 1, 4. Yes. So LHS equal to RHS. That is P of 1 is true. Second step, let us assume for some k belonging to n, P of k is true. Means what? Tk equal to 5 raised to k minus 1. In step 3, we say that we have to prove now that P of k plus 1 is true. That is to prove Tk plus 1. Here, Tk plus 1 equal to 5 raised to, in fact, what they have written, Tk plus 1 is nothing but 5 raised to k plus 1 minus 1. Okay. So LHS. See, this is wrong. This is not 5t. This should be 5 raised to k plus 1 minus 1. This t should not be there. Okay. LHS. tk plus 1. But what is tk plus 1? See, it is 5tk plus 4. 5tk plus 4. Yes, this is the reason. But we have assumed what? We have assumed from 1 that tk is 5 raised to k minus 1. This is not at all difficult. So substitute the value of tk. Okay. Open the bracket, right? You will notice that this is 5 into 5 raised to k minus 5 plus 4. What is minus 5 plus 4? Minus 1. And 5 into 5 raised to k is 5 raised to k plus 1, which is nothing but RHS. So P of k plus 1 is true. Step 4, from all the above steps and by the principle of mathematical induction, P of n is true for all n belonging to natural numbers. That is, Tn is 5 raised to n minus 1, where Tn plus 1 is given to be 5Tn plus 4 and T1 is 4. I repeat, you have to correct this one. See, logic is very simple. In this result, replace k by k plus 1. So tk plus 1. Here originally it is 5 raised to k. Now it will change to 5 raised to k plus 1 minus 1 as it is. So this t should not be there. 5 raised to k plus 1 minus 1. See, we have got the same. Okay. 16th one, prove by method of induction. Matrix 1, 2, 0, 1 raised to n is 1 plus 2n, 0, 1, n is a natural number. Step 1, let Pn, or before that, let Pn denote the given statement. Step 1, for n equal to 1, what is LHS? Raised to 1 means same matrix. So 1, 2, 0, 1. RHS, replace n by 1. I hope you won't say this is 121. This is 2 into 1, right? So the same matrix 1, 2, 0, 1. So LHS equal to RHS, that is P of 1 is true. Second step, let P of k be true, where k is a natural number. So 1, 2, 0, 1 raised to k is which matrix? 1, 2k, 0, 1. This is first result. We now prove that P of k plus 1 is true. That is to prove 1, 2, 0, 1 raised to k plus 1 is which matrix? 1, 2 into k plus 1, 0, 1. That is 1, 2k plus 2, 0, 1. Okay. Begin with LHS. So LHS is 1, 2, 0, 1 raised to k plus 1. Laws of indices 1, 2, 0, 1 raised to k into this matrix again 1, 2, 0, 1. But this is what? From 1. This one. 1, 2k, 0, 1 multiplied by this. You should know that matrix product is a row by column product. Both are square matrices of order 2 by 2. So the product matrix is again of order 2 by 2. So first row, first column, 1 into 1, 1 plus 0. Then 1 into 2, 2 plus 2k into 1, 2k. So 2 plus 2k. What about this element? 0, 1, 0, 1, 0, 0. 0, 2, 0, 1, 1, 1. Yes, this is right hand side. So P of k plus 1 is true. So from above steps and by the principle of, you should write mathematical induction, P of n is true for all n belonging to natural numbers. That is, matrix 1, 2, 0, 1 raised to n is which matrix? 1, 2n, 0, 1, where n is a natural number. Actually, we will be discussing two sums from the topic matrices, miscellaneous exercise. We could not do these two sums at that time because as you know that method of induction is required for this. Now we have discussed method of induction, so we are in a position to discuss the solution. If a is 3 minus 4, 1 minus 1, prove that a raised to n is 1 plus 2n minus 4n, n 1 minus 2n for all n belonging to n. Since the result to be proved for all n belonging to n, we will use method of induction. Let Pn denote the statement a raised to n equal to. For n equal to 1, we get a raised to 1, that is this matrix. Now, what is RHS? 1 plus 2, that is 3, minus 4, 1, minus 1. Yes, so P of 1 is true. Now we assume that result is true for n equal to k. That is a raised to k equal to which matrix? 1 plus 2k minus 4k, k 1 minus 2k. Number 1. We now prove that P of n is true for n equal to k plus 1. Actually, we prove that P of k plus 1 is true. Same thing. That is to prove. See, replace every k by k plus 1. That is to prove a raised to k plus 1 equal to 1 plus 2 into in bracket k plus 1. See, some students write 1 plus 2k plus 1 and then say that induction is difficult. Induction is not difficult. You do not know the basics. That is the main thing. So if you open the bracket, you get this. So what is to be proved? A raised to k plus 1 equal to 2k plus 3 minus 4k minus 4, k plus 1 minus 2k minus 1. Begin with LHS. As per laws of indices, a raised to k plus 1 is a raised to k into a. But a raised to k is this from 1 into this. Now you should know how to take the product. Matrix product is row by column. So first row, first column. So 3 into 1 plus 2k minus 4k and so on. So all the 4 elements are obtained. It is found that LHS is same as RHS. Therefore, P of n is true for n equal to k. Then it is definitely true for n equal to k plus 1. Hence, by the method of induction, P of n is true for all n belonging to capital N. That is. Okay. Yes. The next one was 24th. This is matrix A. Prove that A raised to n equal to. Same logic. Put or before that let Pn denote the given result and so on. LHS A raised to 1, that is A, which is this matrix. Put n equal to 1 in the right hand side. Yes, cos theta, sin theta, minus sin theta, cos theta, same. So P of 1 is true. Now we assume that P of n is true for n equal to k. So A raised to k is which matrix? Cos k theta, sin k theta, minus sin k theta, cos k theta. We now prove that result is true for k plus 1. That is to prove A raised to k plus 1 equal to, don't say cos k theta plus k, you have to say cos of k plus 1 into theta, sin of k plus 1 into theta, and so on. LHS A raised to k plus 1 is A raised to k into A. But from 1, this is A raised to k. You know how to take the product of matrices. I will explain, say, this element. Second row, second column. Second row from the first matrix, second column from the second matrix. Why? Matrix product is row by column product. So minus sin k theta sin theta plus cos k theta cos theta. Now cos alpha cos beta minus sin alpha sin beta is cos of alpha plus beta. That is cos of k theta plus theta. Take theta common to get this. You will notice, similarly you can obtain the remaining 3. You will notice that you have got right hand side. This means if P of n is true for n equal to k, then it is also true for n equal to k plus 1. Hence, by the method of induction, P of n is true for all natural values of n. That is A raised to n equal to this.